This lesson looks at quadratic function properties and their graphs. A quadratic function is a function in quadratic form like this. This is actually the standard form of a quadratic function, ax squared plus bx plus c. So let's take a look. The standard quadratic form, the basic format, gives us a parabola. And we're going to see what a parabola looks like once we look at graphing f of x equals x squared. That's the underlying shape of any standard form quadratic. So let's just plot out some points and consider what these points are going to look like when we graph them out. So if you take -2, that'll be -2 squared, which will give 4. So for an input value of -2, you get an output of 4. And an input of -1 will give you an output of 1. So essentially any input that you're taking will be squared. So 0 squared will give us 0, 1 squared will give us 1, 2 squared will give us 4. And you'll notice there's some symmetry going on. This line of this axis of symmetry is in the center in this case, because at 0, 0 squared is 0. Everything positive squared will be the same as everything negative squared. Now, you don't want to just jot them like with straight lines. Think about the little tiny amounts, like say 0.5. What's 0.5 squared? It's actually a quarter, it's not half. And 0.25 squared is actually, because that's a quarter squared, that's going to be a 16th. So it's actually quite flat at the bottom, and then it curves up and grows exponentially. And this is a parabola. So let's talk about some of the properties of quadratic functions and therefore the properties of the parabola. So the shape is a U-shape. So the shape is a parabola. It opens up. The domain is all real numbers. The range is everything from 0 to infinity. The vertex is at 0, 0. And the axis of symmetry is defined by x being equal to 0. That's this axis of symmetry here. So next up, we're going to look at how we can take this parabola format of f of x equals x squared and look at how we can alter it. So let's make some changes to our general format of f of x equals x squared. That is the underlying format. So what happens if we add 1? So I'm just going to graph in red the parabola that we had previously. Now let's take a look at what happens to all these points when we add 1. So remember, this was, for -2, this was a 4, this was a 1, a 0, a 1, a 4. If we add 1, that's going to make 5, 2, 1, 2, 5. So everything has shifted up by 1. So you can see adding 1 to the outside like this has made it go up by 1. What about if we took away 2? Well, all our numbers that we had found for the squaring bit are now being dropped by 2. So the original graph, every point, every output at that input is being dropped by 2 places. So you can start seeing that there are some patterns with how you change the formula and what it does to the graph. So if you know your basic formula and what it looks like, then you can get a better understanding of what it's going to look like when you make the changes. So let's take a look at the next one. What if we add 1 inside the bracket? So that's a little bit of a difference. If you add it outside, it's just affecting the outputs directly up and down. But if you do it to the inside, it's going to make it a little different. So now, if we put it in, then we'll have -2 plus 1 squared. So that -2 is first being added by 1 and then being squared. So what's that going to do? Well, that's actually changing the input. Rather than being a -2, the input is now the same as if it were a -1. So rather than the input being here at -2, it's as if it's here at -1. So that's going to cause a shift, a left and right shift. But which way is it going to go? Do you think it's going to go right or left? Well, let's see. This will give us -1 squared, which will be 1. So at -2, it's going to be whatever it should have been at -1. So it's actually shifting left to what it was. Let's keep going. Let's try another one. -1 is being added by 1, but now it's going to be the same as an input of 0. So at -1, we now have a 0. Similarly, the 0 is now what it would have been at 1. So although it seems like it should shift right, it's actually shifting left because the point that was to the right of it is now being brought back 1. So you'll see that at 0, now you have 1. And similarly, the 1 will be 2 squared, which will be 4. And the 2 will be 3 squared, which will be 9. So you can see that it's being shifted to the left by 1. And let's try that again. What do you think is going to happen in this case? You're minusing 2 from the inside, meaning you're taking the x and essentially lowering it by 2, but then placing it there where it is. So actually it's going to be moving to the right by 2. Let's try that and see what happens. -4 squared, 16. It's a little off our graph, so let's keep going. So that's -3 squared will be 9. 0 minus 2 will be 4. So that one's easy to graph. So 0 will be at 4. 1 will be at 1. And 2 will be at 0. And you can keep going. 3 will actually be at 1, and 4 will be continuing this pattern here. So it's actually shifted right 2. This one was down 2, and this one was up 1. So those are interesting shifts to pay attention to. Remember, the shape of the graph can also be changed if we multiplied everything by a certain number, like 5 or something, and so all these would be multiplied by 5, so the shape would be changed. So let's take a look at how we can alter these more in a more general form. And let's take a look at the Desmos calculator online. You can go to it just by going to www.desmos.com and you can play around with it. So this is a little graphing tool. It's nice and smooth and allows you to play around with making some changes. So let's say you had y equals x squared, and there it is in black. Alright, let's make another function. So y equals, say, x squared, but let's this time add 2. And we saw that went up by 2. What if I type add 6? Goes up by 6. Subtract 5. Goes down. So we can actually, in this program, put plus a letter like B, and then you can add a slider, and what this means is it'll alter B as you move it. So how is B moving? It moves up and down. If it's positive, it's moving up. If it's negative, it's moving down. Okay, but what if we take that and alter inside as well? So what's going to happen if inside this x squared we have bracket x, say, plus h bracket squared, and then plus b. So now we have two sliders. We have the inside variable that can alter and the outside variable that can also alter. Those are constants that in your formula you would get. But let's see what happens if we move h. This one's a little different. If we move it to the negatives, it's moving right. To the positives, it's moving left. And the b, how does it move? It moves it up and down directly. So at any given point, let's talk about where this vertex is. The vertex is the point right there, and see how it's showing it to us when we click on it? It's negative 6.4 comma 2.1, and that's directly what the h and b are. So that's one thing to pay attention to, is if you're looking for the vertex and you have it in this nice format of squared, and then you see what's affecting the x and what's affecting the y, you can see that what's affecting the x goes opposite sign into the variable, into the coordinate point, and the b part goes directly just as it is. So that's important for two reasons, and one is that we can easily find a vertex, and the other is that this format is very helpful, and to get a standard format quadratic into that format, we will need completing the square. But we'll deal with that later. There's one more thing that we can change. Other than adding and subtracting, we can also multiply. So there's a constant that we could have here, such as a, and let's make a slider for a and see what that does. Right now it's at 1, but what if I make it bigger, like say double or quadruple times 5? See how it became narrow? That's because every single one of those points was multiplied by 5 and therefore became taller. So a bigger constant at the front will make it narrower, smaller, getting close to, notice when it's 0, it becomes a flat line. Did you see that earlier? I can't quite get it to that. But as soon as it gets to 0, it gets flat. But then as soon as it gets to, there it is, 0 is flat. As soon as it gets to negative, it then again just flips down and then becomes tall and narrow for big numbers and wide for very small numbers. So if your number is smaller than 1, it's going to be a wider parabola. So play around with that and just notice what the A does, what the H does, and what the B does. So now that we've played around with the Desmos calculator, hopefully this gives you a better idea of how to graph such a an equation that's in vertex form. It's in vertex form because remember, this tells us the vertex, the x shift and the y shift. So the vertex, remember, it was always the opposite of the inside of the bracket and directly what the outside is. So 2, 1 is the vertex. How is it opening? So first of all, it's a parabola because it's something squared with a variable inside. It's opening down because it's negative, but it's a 1 coefficient. So it's going to open just like a standard parabola where 1 is a 1, 2 becomes a 4, the squaring property. So I didn't even have to plot any points. I was just able to use the properties to graph it. What's the domain? Domain is everything because all real numbers can be input into x. However, only numbers up to and including 1 are being output. And the axis of symmetry is always determined by the x value of your vertex, which in this case is 2. So x equals 2. So here's a summary of observations that we have made for the vertex form. Now, this is vertex form, standard forms like that. So remember, you can complete the square to get from standard form into vertex form, where vertex form is super helpful. It's helpful because it tells us all this information, right? If your A is positive, that means positive, it opens up. If it's negative, it opens down. The domain's always all real numbers. And the range, you can see it as depending on whether it's positive or negative. If it's opening as positive, opening up, then the range is from your vertex value there, where the vertex is the y value of the vertex, and up. Whereas if it's pointing down, it's everything up to and including the k value, where the k value is the vertex. So here they're using k, not b, but that's arbitrary. So hk is the vertex, and the line is x equals h. So I mean, this is a summary. This looks a little complicated, but if you go back to the idea that this and this create the vertex. Once you have the vertex, you have the line of symmetry as it depends on the x. You also have the range. If it opens up, you know it's everything from that point down. If it opens down, you know it's everything from that point down. Let's look at some more examples. So here, again, the shape is a parabola. The vertex is determined by our h and k, so that'll be 3, 1. Our axis is going to always depend on whatever the x value of the vertex is. It's positive, so it's opening up, and the domain is always all real numbers. You can write this or you can write this. Now the range is going to be depending on if it opens up or down. So if it opens up, that means it's going to be everything from the k value, which is 1, to infinity. Now let's try and graph that out. So the vertex is 3, 1, and it opens up. However, it is altered in shape. All of the points from the regular parabola are being halved. So instead of going 1, 1, it's going 1/2. 2, 4 is going to 2. And so on. So that kind of determines the shape. If you know your standard shape, then you can alter it easily. This one, again, it's a parabola with vertex -3, 2. Axis of symmetry is at x equal -3. And it's opening up because it's positive. So that determines our range because it'll be from the y value there of 2 all the way to infinity, domain being all real numbers. Starts at -3, 2, opens up, and everything is doubled. So instead of 1, 1, you have 1, 2. 2, 4, you're going to have 2, 8. It's going to be really high. So it's going to be tall and narrow because it's all the numbers are being multiplied. And here's another one. Again, shape is parabola. Vertex is -1, 2. Axis is x equals -1. It opens down. Domain is always all real numbers, and the range, because it's opening down, is from the k value all the way down, so -infinity up to 2 including. So when we draw it, we start at -1, 2, and it's opening down, and everything is taken down by a third. So instead of 1, 1, it's 1, 1/3. Instead of 2, 4, it'll be 4/3, and so on. So if you really like, you can find some more points to make it more accurate. But it's going to approximately look like that.